A self-driving car needs to be able to quickly respond to changes in driving conditions. A factory needs to be able to quickly respond to changes in workplace safety. For these kinds of applications, we need processing power closer to the user of the application. If we put all of our application logic in the cloud, we're going to have to make network round-trip requests for every request that we send to the cloud. Servers in the cloud are powerful, but so are the computers at the edge. Smartphones, sensors, drones, cars. You can even put servers on-prem, which used to be the norm. Today, edge computing is giving us more computation outside the data center. We're getting towards a world where you've got compute in the data center that you do some of your compute in, and you've got compute at the edge that you do other types of computing at. And we're going to talk about those different use cases in today's show. Olivier Bloch works on Microsoft Azure IoT Edge, a set of services for edge computing. Azure IoT Edge includes on-prem versions of Microsoft Azure technologies. These are tools that were previously accessible only in the cloud, and Azure IoT Edge allows you to deploy and host them on-premise. Before we get to today's show, Software Engineering Daily is looking for sponsors for Q3. If your company has a product or a service, or if you're hiring, Software Engineering Daily reaches 23,000 engineers listening daily. You can send me an email, jeff@softwareengineeringdaily.com, if you've got something interesting and you're looking to sponsor the show. With that, let's get to this episode, IoT Edge with Olivier Bloch. Do you want the flexibility of a non-relational key-value store together with the query capabilities of SQL? Take a look at cTreeAce by Faircom. cTreeAce is a non-relational key-value store that offers ACID transactions complemented by a full SQL engine. cTreeAce offers simultaneous access to the data through non-relational and relational APIs. Companies use cTreeAce to process ACID transactions through non-relational APIs for extreme performance while using the SQL APIs to connect third-party apps or query the data for reports or business intelligence. cTreeAce is platform and hardware agnostic, and it's capable of being embedded, deployed on premises, or in the cloud. Faircom has been around for decades, powering applications that most people use daily. Whether you are listening to NPR, shipping a package through UPS, paying for gas at the pump, or swiping your Visa card in Europe, Faircom is powering you through your day. Software Engineering Daily listeners can download an evaluation version of cTreeAce for free by going to softwareengineeringdaily.com/Faircom. Thanks to Faircom cTreeAce for being a new sponsor of Software Engineering Daily, and you can go to softwareengineeringdaily.com/Faircom to check it out and support the show. Olivier Bloch is a program manager with the IoT Edge team on Microsoft Azure. Olivier, welcome to Software Engineering Daily.
Thank you, Jeff.
So over the past 10 years, we have seen a lot of computation shift from on-premise to the cloud. And over the next 10 years, it looks like we're going to see even more growth in cloud, but also growth in devices at the edge. And today, these are things like sensors in a factory, or your internet-connected refrigerator, or your smartphone. And there's going to be growth in drones and self-driving cars, and all of these things are computers, and they have spare computation power. So this means that we can push computation to the cloud or to these devices. So generally speaking, when we have this huge array of different types of devices in the world, as well as this cloud that is this giant area of computation, how do we decide where to put our computation?
So it all depends and comes down to the type of scenario you're implementing. So just to go back on what you just mentioned, I think that the evolution over the last 10 to 20 years on the device side of things has been more about actually having these devices being more and more powerful and more smart and more connected, because the capabilities of the microcontrollers, these little tiny computers running there, as well as the price of memory going down, what we're seeing is a huge growth in terms of what these devices could do. And at the time where it was not powerful enough to actually make decisions based on data or store enough data to do analytics on that data, obviously the cloud has been here to the rescue to handle all these compute and storage tasks. And now what we're seeing is that the device side of things has become such that it's not possible to start distributing your intelligence. It's not so much about doing it back and forth, it's actually about doing the right thing at the right place. And now, because these devices are more powerful, what you can start doing is not send all the data to a remote compute unit. You can actually now start doing things here locally on your device. And you can specialize these tasks for what the device is doing. And so I think when it comes to, hey, where should I run what, it very much comes down to what is your scenario? What is it trying to achieve? Where are the critical aspects of your solution? And this is where actually you enter into this kind of discussions. And typically a question you will ask yourself is, do I need and do I want to pay all that bandwidth to send all that telemetry data to the cloud? Because in a nominal situation, everything goes well, I might not need that data. What I need is actually to receive information when something goes wrong. In which case, you ask a question to yourself, which is, hey, can I determine that something is wrong down at the edge on the device or not? And this is where you start asking, hey, can I run the specific algorithm down close to the sensors, or do I need to run it in the cloud based on how much data and how much power I have locally? So then it comes down to that scenario-based context that you have.
I have done these shows with Netflix, and I talked to Netflix about building their scheduler, and they build schedulers essentially entirely for cloud resources. So just if you're looking at a data center and you've got this number of machines that are available and you've got this number of jobs that you need to get done, you allocate these jobs to these machines because this is the way that needs to get done. And that in and of itself is a highly complex process. But here you're talking about this is a much richer set of problems because well, for one, there's just more sensitivity to, or there's a wider range of sensitivity to the tasks that need to get done. I mean, in Netflix, there's pretty good failover for a lot of the scenarios. Like you can just fail over to the default, and it's like, okay, you've got an index of movies, and you just need to be able to play movies. And most of the scheduling that they're doing is like, how do we forecast what movie to recommend to somebody? But if you're talking about IoT, you're talking about forecasting, okay, is there going to be a car in the road in the next 10 feet? Or is there a safety hazard on my construction site? And these are things where you need a much higher degree of sensitivity. So what changes in this world when we have these higher demands on the processing systems and the machine learning stuff? Because it seems like we need a different type of scheduling strategy.
So I think you're actually lighting very interesting scenarios here. What is key here to solving these kind of issues is exactly what I mentioned, which is running the compute on the data at the right place at the right moment. So for the scenario of detecting issues or problems and foreseeing problems, such as in a car situation or in an industry situation like a factory floor, you need to have reaction times that are very low. I mean, you need to instantly react. But based on what? Yeah, you have option one, which is actually you have sensors locally, and you can pre-configure thresholds. And so your device is powerful enough to say, hey, when that value goes above that, let's stop everything. And it's kind of binary. There's not a lot of refinement in terms of what can be done in terms of reaction. So the other option is to have some bigger unit doing the compute for you based on a bunch of data. So then you enter into that idea of, hey, let's push all the data from all these vehicles, for example, or all these robots in the factory floor. Let's push them all to the cloud and have some rich machine learning algorithm being trained based on all that data. And then you have a model that can be applied to real-time data and detect these anomalies and eventually react. However, you still have in that situation the round trip to the cloud, which is a problem in terms of the latency, in terms of reaction time. So now, with technologies such as Azure IoT Edge that we just announced, you can think of starting distributing that. So if you need to have a specialized model on specific data to be executed, to be run as close as possible to that data, you can train the model in the cloud and then deploy it at the edge on the devices. And this is actually the type of complex scenarios that we are trying to solve, allowing a continuous training of these models based on a lot of data that goes to the cloud, but then leveraging these compute units that can be run on the devices at the edge to execute these very specialized models that have been trained up there and reduce latency time, have reaction happening at the edge, but have a reaction that is no longer based on thresholds and I would say dumb type of limits or pre-configured and hard to update type of limits. This is something that actually will be happening on very smart algorithms that will be executed super fast because they're very much optimized. And then the other thing is, how do you manage all of that? Because updating software on a device, we know how to do that, but it's complex, it's hard, it's long, and it's tedious, and you have all the security aspect of it to take into account as well. You don't want some random software to end up into your car controllers, right? And so at the end of the day, beyond the capability, the ability to run, compute services at the edge, what actually is also a big value and helps the customers right now, because that's what they need and looking for, is a way to manage that intelligence, a way to deploy it, a way to update it, all of that in a secure way, and all of that controlled through an interface which is very practical from everywhere, which is the cloud. And so this is actually, there's two aspects: the runtime on the devices capable of running that intelligence, and all that orchestration and management of both the devices and which entities are running on these devices, that is key. And basically that is exactly what developers are looking for and our customers are searching and in need right now.
So I saw you at Microsoft Build, and there were a number of presentations about manufacturing and construction companies at Build. They were talking about IoT, and these companies they're typically outfitting their machinery with lots of sensors, and they want to do predictive analytics. They want to do predictive maintenance. They've got a lot of old technology, and they're often integrating newer technology with the old technology. What's the process for deploying something like an Azure IoT solution? Like, how do you onboard them?
So we actually are seeing that, and we have different names for that. The area where some customer already have an existing, we call that the brownfield, and when they are going new with a new type of project, it's greenfield. So brownfield is most of the situation when you think today about typically the industrial automation scenarios. When someone builds a robot and someone buys a robot, actually, they're expecting that to be working for the next 10, 15, 20 years. They don't want to change that every now and then. And so when it comes to these kind of scenarios, these devices locally already have tons of sensors that are basically feeding into equipment such as PLCs that are like kind of local computers that do all that work of processing real-time data and taking action based on complex configuration of thresholds and so on. So the first step for this kind of customers is to apprehend the fact that you can integrate into your IoT infrastructure, existing infrastructure, a gateway or a set of devices that will act as their interface to a broader system. And when I say broader system, I think about the cloud as one entity to be connected to, but you can think as well about private cloud solutions, on-premise type of clouds, or their own infrastructure, because actually there's also the need to eventually hook up these machines and these infrastructure into their own line of business applications, to trigger maintenance, optimize their customer relationship management and things like that. So the first step is really to look into how can I inject into that infrastructure smart and connected devices that will, on one hand, get the data from these devices, send them to that cloud entity or backend, allow for analytics using very advanced services on that data, and then take action by re-injecting commands down to the devices. So that interface with brownfield infrastructure is done through gateways, it's done through protocol translators and things that we have in our portfolio that can help the customers, let's say, cloudify their existing solutions. And then there's the other type of customers where we're actually starting fresh, and in that case, it's even easier in terms of implementing a solution because, they start fresh, and these devices will themselves be connected and smart enough to do some number of things. But both scenarios, both type of approaches are addressed here, and we definitely have in mind the fact that customers are not always starting fresh, and so that brownfield type of scenario is key. It's actually very much more than just adding a Wi-Fi chip on an existing machine. Security is something that these customers have to take into account very seriously because they were on a closed environment. They were like totally safe in their environment and were able to have a full control. But now they need to think security. They need to lock things down. And this is where they can benefit from an infrastructure and tools and SDKs that give them that security out of the box. So I would say this is definitely the two angles to look into. How do you extend an existing solution, and how you lock down securely, all the connectivity and so forth.
So when I think about manufacturing and construction companies, these are the kinds of companies that I imagine as being slow to the cloud, similar to banking or finance or healthcare, where they say, we're not so sure about this whole cloud thing. But what you just said there made that argument a little more rational to me, because essentially what they would have to do to go onto the cloud is open up some endpoints that expose them to what feels like a riskier situation than just running this, I guess what they would have run in the past, which is kind of like an intranet where they have complete control over everything.
Exactly, and actually this is something that can be done in a very bad and fast way, which is like not securing all of that. And we've seen in the recent past that this is not really a good idea. But this is definitely one of the factors that makes these industries not slow, but more cautious in terms of adopting the cloud.
Because if you get it wrong, you get ransomware.
Well, you get this kind of things. Yes, if you get it wrong, you can get in big trouble. You can lose data. You can actually have, man-in-the-middle type of attacks and things that actually can compromise your business, and privacy and all these aspects of things. And so this is that aspect which is kind of slowing them down. But they're getting to it, and they're learning that it can be done safely. It can be done securely, and for that, they need to have the right tools, the right infrastructures. The other aspect to that, not slowness, I would say, but I would qualify that as cautiousness. These customers are very cautious, and the other reason is sovereignty of data, where basically for lots of them, the core of their business is around IP that they built around data. So a good example could be the one we showed at Build with Sandvik Coromant, which is that company building this high quality and precision metal cutting machines. And what's happening is that what they have a business on today is, or yesterday, what they had a business on was on having these very advanced and efficient machines. But they're not the only ones able to do that now. So they're shifting their business model to provide services for having a better efficiency at how these machines are used. And so basically they gather a lot of information from all these machines that are across the world in these factories, on these factory floors. And what they do is they determine what's the best use for these machines and tools, and basically feed their customers with that information, like suggesting when to use what and where to use that tool versus this other one, and how to reuse that tool while it's not used on that machine, on that other machine down there that is not running at the moment, and things like that. So basically optimizing workflows and optimizing production. So they're now shifting their model to, we still build very advanced machines, but we also sell the service, and that makes the value of these machines, which is the service that comes with them, that allows to save a lot of operational money. And so they are actually differentiating from their competitors thanks to this kind of solutions. And so this is another shift which is very hard for them, which is switching their business model and being able to face competition in a different way. And this is very hard for lots of industry actually.
Ready to build your own stunning website? Go to Wix.com and start for free. With Wix, you can choose from hundreds of beautiful, designer-made templates. Simply drag and drop to customize anything and everything. Add your text, images, videos, and more. Wix makes it easy to get your stunning website looking exactly the way that you want. Plus, your site is mobile optimized, so you'll look amazing on any device. Whatever you need your website for, Wix has you covered. So showcase your talents. Start that dev blog detailing your latest projects. Grow your network with Wix apps made to work seamlessly with your site. Or simply explore and share new ideas. You decide. Over 100 million people choose Wix to create their website. What are you waiting for? Make yours happen today. It's easy and free. And when you're ready to upgrade, use the promo code SEDaily for a special SE Daily listener discount. Terms and conditions apply. For more details, go to www.wix.com/wix-lp/SEDaily. Create your stunning website today with Wix.com. That's Wix.com. For some of these companies, the term machine learning, all that means is maybe gathering data on, let's say, just some atmospheric check, like the amount of gas of a particular type of gas in an area of a factory, and being able to respond to that. And simply, if you have enough of a certain gas in an area, maybe you send a signal to shut a door somewhere or open a vent somewhere, and maybe it's learning to predict what are the factors that lead to that kind of gas being in the air. So it could be something very simple like that, and then there are much more complex models that these kinds of companies would want to build. What are these companies asking for in the way of machine learning?
So it's actually different type of things. The first one they're asking for is because machine learning is complex. I mean, let's just say it. It's hard. I mean, it takes data scientists to determine models and work on them. And the other aspect of it is, of the complexity, is that data scientists might not know a domain of application of data. And so there is a need for a collaboration between what the industry is used to and the data they have and they own and they know how to use it and what it means and so forth. And the data scientists need to make sense of that data through rich algorithms, through machine learning runtimes and compute powers. But at the end of the day, the thing that the customer is asking is simplicity in the complex world that machine learning is about. So first thing, a set of things that they want is a set of simple APIs. And when you think about cognitive services on Azure, this is exactly what it is. As in, if you want to detect anomaly on timestamp data that is sent over, you can actually apply specific anomaly detection algorithms calling one API, one REST API, You send a buffer of data, and this model, this machine learning entity, will learn from the data you're sending and will respond with anomaly detection alerts. And a long time, this algorithm will just learn, keep on learning. The more data you send, the more it will learn, and on its own will be able to determine even better the anomalies. You have other algorithms that could be accessible through APIs, such as face recognition, voice recognition, and others. These are just the examples, that come to mind that talk to everyone, but there's plenty other ones. So having machine learning service in the form of cognitive services in terms of simple APIs solves a lot of the problems customers have. The other one is the possibility of running these algorithms somewhere else than just in the cloud. Actually, and this is new. This is also something that might have slowed down people adopting these algorithms. The ability to train these models, train these APIs in an infrastructure such as a cloud, super easy. You have plenty of nice tools, and you can benefit from existing libraries and APIs. And then you extract some of that, the specialized part of it, the thing that you really need for your machine or your solution, and then bring that down to the edge. And this is actually the other thing that customers are looking for in machine learning, which is making their devices smarter, but not just thanks to a cloud entity that does all the work, also by running specialized algorithms down at the edge.
Okay, so you mentioned a few really interesting things there. The first was that this was this video that Microsoft showed during the keynote, where when you're referring to these cognitive services, there were a couple scenarios that Microsoft displayed at Build where it was totally new to me, and this was a really interesting idea, but basically you have cameras throughout your construction site or throughout your factory, and if there is a situation that needs fixing, then the cameras can detect it. So, for example, oops, somebody left that bandsaw out, and if that's in the wrong area, somebody's going to trip over it. That's a safety hazard, and the cameras can identify that safety hazard and notify somebody, hey, pick up that saw somewhere. You can also identify people on the construction site who you want to remove from the construction site. So that's one part. I mean, you mentioned the cognitive services thing, and I think this is slightly related to the IoT Edge stuff, but I think we should talk more about the machine learning stuff. Anyway, I just wanted to comment on that because you mentioned the cognitive services stuff, and I had seen all that facial recognition and image recognition stuff that Microsoft showed, basically how you can apply that to something like a construction site, and I thought this was just fantastic. And it was so, you see all this stuff like, oh, here's how you can apply better filters to Snapchat or to some Facebook thing, and it's like, cool, that's a nice use of facial recognition, but here we're talking about a real-time way to respond to potentially dangerous incidents on a construction site. I think that's just fantastic.
And as a matter of fact, tying back to Edge, the actual demo scenario has been showcased that you're describing was leveraging Azure Stack, which is an Edge solution to run beefy, huge services down on premise. Because one thing that is hard to do with video like that, imagine the scenario where you have all these cameras to secure that construction site. You have to have good coverage in terms of video if you want to have visibility on all the tools that are around and all the safety hazards that can be seen. And so once you have that coverage, imagine the amount of data that these cameras are sharing. Wow. And so now if you cannot do that if you don't have smarts and intelligence at the edge, because you cannot stream all these cameras on one single GSM connection or whatever it is, or it will cost a lot of money with super expensive fiber optic type of connections. And so basically now, because you're able to bring intelligence at the edge where the devices and sensors are, you can still leverage the power of machine learning cognitive service in the cloud because it runs locally, because you're able to execute these algorithms there. Then you can do these very advanced scenarios. You don't rely anymore on a round trip to the cloud, on very expensive bandwidth usage. Now we can enable these scenarios that previously were not possible, not from the technical perspective, because actually since like video recognition exists, since OpenCV library is open source, doing it's not hard.
Right.
The problem is doing it on hundreds of cameras at the same time and determining actual interesting and relevant information and take action on time to actually avoid the dangerous scenarios, avoid incidents, and go beyond the liability problems that could occur in using such a system. Then it requires having things running at the edge. Hence the importance of having this, intelligent cloud supported by an intelligent edge.
Well, and from the business side of things, what's so great about this is totally in Microsoft's wheelhouse. Like the idea of, we're going to sell you some computers and you're going to use those computers on premise to do your work. That's what Microsoft has been doing for a very long time. And here is yet another scenario where it makes sense for Microsoft to say, hey, let's sell you something that works really well on premise.
Yeah, exactly. I mean, like this is not new. I mean, both from us and from others, actually, the model definitely works really well, and we developed a lot our work in the cloud in the late years, and we are complementing that work with something we've been really good and experienced with, which is all the edge activity. Just as a reminder, my previous lives before my Microsoft life, I was a developer in the embedded space, and some of the best embedded operating systems at the time were Windows CE and Windows XP embedded, things that actually were working super well, being smaller componentized version of Windows and real time for Windows CE, and able to power machines and still have all the security, all the management connectivity, and ease of developing apps for. This has evolved to a point where actually we saw a big interest in working more on the cloud, but now you can see we're reconciling the both, and we are actually now leveraging all our strengths, and definitely it makes sense for Microsoft, but in general, anyways, it makes sense to have this intelligent cloud actually being extended with an intelligent edge. This is what customers are asking for. This is exactly the type of scenarios that they want to implement or try to implement today.
When you're selling a service, well, okay, the idea of a company that has cameras all throughout their factory or all throughout their construction site, do they already have these cameras up and running, or do you need to sell them an entire camera system that's compliant with Windows? What exactly do you have to do for that process?
Yeah, so for that very specific service that has been presented in that demo, I don't know the details myself.
Right.
My understanding at that level is that they work with regular camera that have a decent video quality, because actually what's happening is that they don't require to have a special connectivity to the cloud themselves. They don't need to have a special compression algorithms, because you don't need to compress for sending the data. It's all local, and so basically you can do that with very simple cameras, because you don't need to have all of that in the camera, because you don't need to send the data compressed or already pre-filtered. It's happening at the edge. It's happening down there. So you just like send a raw feed of the camera to the Stack instance that has all these services running, and you do your analytics on that stream of data down there. It's not saying that it doesn't require some beefy set of servers and computers to be installed down there, but you save yourself from the round trip to the cloud or from huge amount of bandwidth to be used, and you save yourself from having to have very advanced cameras that do treatment, themselves of that image. So my understanding is that this service actually will be able to leverage very non-expensive cameras. I don't know about situations where people already have cameras deployed, but I think this is definitely something that we have in mind.
So let's say I've got cameras all throughout my factory, and all these cameras are feeding video data into some computer instance somewhere that's running Azure Stack, I guess? Is that what's happening? So what is Azure?
That's
what is Azure Stack doing? What's the software stack? Is it Windows? What's going on there?
So Azure Stack is actually, think of it as Azure, an instance of Azure running on your own machines. So basically you have a tinier version of what Azure can do, and there's a set of services already supported on Stack that run today on Azure that you can run on Azure Stack. Not all of them are available, but as we move forward with Azure Stack, you're able to run more of them. So when you think about edge intelligence, Azure Stack is one of the options for when you have the infrastructure to run a full instance of Azure. So typically you can run, these are powered by VMs, and the fact that it's Windows, Linux doesn't matter because that's a cloud instance that you're running locally. If you don't have that kind of infrastructure or don't want to invest in that, and you don't have that need of running full-blown services or all of them or huge quantity of data, now you can think of Azure IoT Edge as a lighter solution that still enables you, allows you to run analytics at the edge on tinier devices. So there's that kind of complementarity between Azure Stack and IoT Edge, where IoT Edge is that tinier devices type of targets, and Azure Stack offers you the big guns, I would say, on premise. So in the case of the cameras, we're talking Azure Stack, we're talking about full-blown cognitive services running at the edge on Azure Stack servers in your factory floor in that case.
And can you talk more about the operating system? I guess I don't know much about what Azure would even be running in the cloud to host that information, host those services.
This is you basically would have a runtime that basically is based on Windows, and that allows you to run platform as a service services. So basically, you don't need to care about VMs and all of that. I mean, you can run a VM up there if you want to, but the idea is to offer these services as PaaS. And so you have a platform that has a set of APIs, a set of services there. The fact that they run on that or another is the what's inside Azure itself. It's based on Windows VMs. You don't have to deal with the scaling. You don't have to deal with the elasticity. You don't have to care about the load balancing. That's what the Azure Stack offers you, which is the peace of mind regarding the infrastructure. It's not like you just have a set of servers you have to manage yourself. You have Azure that does that orchestration, load balancing, and so forth.
So if I'm getting all this IoT data, let's say I want to store all of it. Like, let's say I wanted to store all of my video data or all of my centrifuge data or all of the data on the atmospheric information throughout my factory. What kind of database do I use to store all that data?
I'm not aware about exactly what's supported today. We can look online about Azure Stack. There's going to be storage services supported there. And the various databases that are supported, when you look at what Azure has, gives you a good idea what Azure Stack will support. It goes all the way from SQL type of databases to NoSQL ones. There's that new thing that we call Cosmos DB, which is NoSQL type of database that you can leverage. In the cloud itself, there is Data Lake that actually is able to make sense of all these various types of databases and data sources. So there's plenty of options, and basically there's no one that would tell you, hey, you have to use that or that. Okay. It's very much based on your scenario. What do you need? Is it performance? Is it accessibility? Is it, so it's definitely is there available for you to use based on your scenario and your choices. Okay.
So when we're talking about training and deploying machine learning models, does this all take, if I'm a big factory, am I doing some of this machine learning workflow on-prem and some like I'm offloading to Azure Cloud, or what would I do there?
So, usually if you already have, which is like lots of cases out there, your own data scientists work on your data because that's your business model, or because you're optimizing workflows and things like that based on that. Very often, basically today, these data scientists use technologies such as R and other ones that They are supported in the cloud. What you benefit from if you start doing that in the cloud is the scale. Basically, you're not limited to what your local hardware can do and can store. Now you have the unlimited storage, unlimited compute of the cloud, which means that you can train your models even better because you can augment the amount of data that these models use for training. You can also accelerate at what pace these models are trained. And so basically you can leverage the cloud to make that process even better, refine these models. You can also leverage other models coming from the libraries that we have up there for Cognitive Source and others and extend them with our tools. And then when it comes to the execution of a model or the use of a model, because in machine learning you have these two aspects of your model, which is the training, where you reserve a portion of the data that's coming in for training, and then you have the execution of that model on the data to do that real-time analytics or that predictive maintenance or these kind of things, and basically the ability to leverage an edge entity to run this model that has been trained in the cloud is actually very practical for reducing the latency, the response times, for optimizing on the machines. And so basically you can leverage now the two worlds. You can have this world of like unlimited compute and storage of the cloud, and then make the most of that very optimized models all the way down to the edge to optimize on something else.
You could also, if you have a network of factories, you could have all the different IoT data from your different factories being crossed and measured against each other in the cloud.
Exactly. You multiply potentially the sources of information. And so the more information a machine learning model has for training, the better trained it is. Because you multiply the situation, you multiply the patterns the models are exposed to, and so basically you multiply the chances for that model to learn more about the data. So having data coming from lots of places is ideal. And you can imagine that you have like patterns that have been identified in one factory that are a way to predict they're going to have the same problem in another one. You could have a machine that's been positioned in the wrong place in the factory floor because that's next to a big fan that is actually blowing very, very hot air onto it and is going to fail. And then you can determine that it's not because this machine was having a problem, it's because it was not well positioned in that factory, because the same machine in another factory doesn't have the problem. And the only difference is location in the factory. So you can actually, because you gather data from many sources, you can make way more out of the data. The other thing, which is very important as well for the customers, is to differentiate their business, to grow their business. Doing things such as just selling the metal cutting machines we're talking about, to go into a business where you can actually have services sold to your customers with the machines, helps you differentiate your business, augment and grow your business. So because you have the ability of gathering all that information from the various factory floors from your customers, and then mix and match that data and re-offer that matched data or analyzed data as a service back to your customers. Now you're able to offer that value on top of your original, business.
Artificial intelligence is dramatically evolving the way that our world works. And to make AI easier and faster, we need new kinds of hardware and software, which is why Intel acquired Nirvana Systems and its platform for deep learning. Intel Nirvana is hiring engineers to help develop a full stack for AI, from chip design to software frameworks. Go to softwareengineeringdaily.com/Intel to apply for an opening on the team. To learn more about the company, check out the interviews that I've conducted with its engineers. Those are also available at softwareengineeringdaily.com/Intel. Come build the future with Intel Nirvana. Go to softwareengineeringdaily.com/Intel to apply now. So if I'm let's say I'm a factory and I'm collecting all this data on my centrifuges, maybe I can resell that data to some data broker who aggregates information about centrifuges.
That could totally be a use case or a scenario.
Pretty interesting.
Yes. And actually, the one I was thinking about and describing is actually a scenario that our customers are implementing, which is more about, when I'm selling these machines, rather than just selling the machines, let me gather the data they're producing. Like, for example, we have customers that are building coffee machines, like professional brewing machines that are visible in some coffee shops here and there. And so these machines, just being locally logging some information is not good enough because very often they fail for someone to be sent for maintenance, or sometimes you send someone to do a maintenance on a machine that doesn't need to be maintained. And so basically having this machine starting, sending their data, then not only you sell the machine, but then you say, hey, you know what, for that monthly subscription, I'm going to optimize your maintenance, and it's no longer going to be about one guy coming every month to you. It's going to be when it needs to come. And the other thing is, on the usage of other customers, I'll be able to provide some predictive information about your own machine here, and I'll be able to tell you, you know what, you should turn your machine off at night because actually other customers who are doing that, they're saving that amount of money. And so basically now you enter into that relationship with your customer, which is no longer just about selling and maintaining a machine. It becomes a joint venture of optimizing the business of that coffee shop and saving money in other areas. And so that could be, a trade, and a customer might be willing to go with your coffee machine because it comes with that additional service with it. And so you have this kind of new type of businesses and relationships that can be built.
So the world that we've been discussing with the construction sites or the factories, this is a world where the model of computation is still pretty well defined. So it's kind of a client-server model where you've got the client. The client is the entire intranet of the factory. It's the cameras that are feeding into the Azure Stack server, and you've got some sensors around your factory and stuff like that. And then for certain use cases, the Azure Stack on-prem thing is going to communicate with the cloud and do some stuff. That's pretty well defined, and I can see like a lot of really good use cases there. I can also see a lot of room for growth. What do you think of the self-driving car and drone space? Because this is a little less well defined, because we're going to have these things that are just flying around or driving around, where they're going to have intermittent connections, and then we've also got our smartphones, of course. This is a different model of edge computing because there is such a dynamic mesh of different devices that are moving around. Are you starting to think about this space as well?
Oh, definitely. And I think that the elements that you mentioned are spot on, which is the new problematics that these areas are bringing, the non-continuous connectivity, the interaction. You didn't mention that one, which is pretty key, which is the interaction between these entities and devices. Because when you're offline, and like typically think about the drones, two drones are flying in the air, they're going to enter into collision mode. Well, they need to negotiate in terms of, hey, are you turning right or am I turning right? And so there is a few things that will need to happen there. And basically are happening because we are involved, other companies are involved, and we want to define a common ground for implementing the right things. The edge intelligence helps a lot. Like, think about when you are able to download or to actually deploy onto drones new set of models for that kind of interaction with other entities around them. Or, if you want to, you've learned a new pattern based on temperature and pressure and wind and, location of obstacles. And then you say, wow, if I could actually have that deployed now, I would prevent like lots of drone wreckages. And then you're able to do that thanks to the edge intelligence deployed from the cloud. But you don't need the device to be permanently connected because now it can run that model locally. And then you have that communication. We have more and more sensors, more and more technologies that we're looking into. You have technologies about low battery, low consumption networking. You have technologies about very fast throughput for data, which with LTE5 and things like that. So basically, all these new technologies accrue to making these scenarios possible. And having drones, having self-driving cars, in terms of pure technologies, this is not new. In terms of the means for making it happen, this is where things are new. And the aggregation of all these technologies, we're looking very closely. We are working on that on our own and with partners and with customers to make these happen. So there's nothing to announce here, but there will be no surprise that we are working with these partners in these areas. And when you see that we showcase cars, we showcase things like that, it's because we're involved in that world. It's not new. You heard about FortSync in the past, and we have plenty of interactions in cars. And now we're working more and more on providing a backend, a cloud with intelligence, the predictive maintenance, and so forth. And obviously, we'll come to working on these devices that communicate with each other and are able to interact and create these new types of scenarios that are a bit crazy to think about today, but that will be totally normal for our kids in a few years from now.
Help me expand my understanding of the kinds of businesses that are being built with IoT-related technologies. Can you talk about some of the success stories or some of the interesting cases that you've worked with on the Azure IoT team?
So there are some very interesting ones. I remember one around working with Schneider on optimizing the energy consumption on remote sites in Africa for schools and other buildings like that. In situations that are complex and they're actually remote and that are hard in terms, and harsh, I would say, in terms of environment, having the ability to analyze the data that is generated by in that case it was HVAC systems and other sensors in these buildings, you were able to optimize the use and the consumption of that rare energy down there and allow then these buildings to be used by inhabitants for storing food, for schooling, for all these kind of things. So you have this kind of very nice looking type of project. But then I can think about scenarios that are more practical, I would say, such as the Sandvik Cormont example, where a company that was quote unquote just building high precision industrial machines. Now they're selling services along with them. They expanded their business and they went onto that thanks to the IoT scenarios that are now possible with the connectivity, with the smart and intelligent cloud and so forth. We can list a lot of them, and they're very often in the vein of, hey, I had this bunch of devices, they were pretty dumb, doing nothing, but now, because I'm able to make sense of the data they're producing, now I can do A, B, or Z, C, and basically I'm able to do new things thanks to that. And I was always making fun about, hey, IoT is that new thing. It's not new. It's been we've been doing connected devices since 20 years ago. We've been doing smart devices 10 years ago. We've been doing connected devices 5 to 10 years ago. And the difference right now is that we found a name for it, and we do have machine learning AI that are coming into the fray of these scenarios. They're bringing that intelligence that allows making sense out of data and taking action, which is that second step, and that brings things back to the human, to that interaction that we need to have with these machines for these scenarios to be viable. And so this is very much the way I see the future going towards, which is having a richer interface with the humans, and having actually the humans taking a greater part in these scenarios than we think. Because we very much often think about IoT is going to replace humans, going to kill jobs, and I'm convinced on the other hand that it's going to be the opposite, because we actually will optimize that interaction, will make the human more efficient, and will make that interaction more beneficial at many levels. So this is my vision about the future. I'm an optimistic, and I love what I'm seeing. I think it goes super fast. It's very impressive how technology in that area is growing, and how we are seeing now the merge or the overlap of these technologies. AI on one side, IoT developing on the other one, the communication technologies on the other one. So all of that comes into place. There's an area we didn't mention, which is actually totally integrated, which is all the mixed reality and augmented reality. There are domains that totally align, complement, go along with IoT and AI. If you combine all of that, you have what our very near future will look like.
And where does that take you?
Me personally, or
well,
I think the movies we're seeing are not even close to what it's going to be. I mean, the seamless interaction with your environment and with things that are not even like close to you, whether they're devices, whether they're people, whether they're services, all that interaction will become more and more seamless. And where honestly I see things going is to a place where these put together will make our lives easier and simpler, and will allow us to spend quality time on important things. And so I like to think that where we're going is it might sound a bit cheesy, but towards a better world, based on the fact that these systems will support the humans to do better with everything we're doing.
I'm with you. I agree. I think that's where we're going to. Okay, well, Olivier, thanks for coming on Software Engineering Daily. It's been a pleasure talking to you. I enjoyed meeting you at Microsoft Build.
Well, thanks for having me, and hope we talk soon.
Gatsby is an API for running promotions. It's the sleekest and smartest promotion platform. If you want to run a promotion for a discount or some sort of call to action campaign, Gatsby is the choice for you. It enables customers to increase conversion through elegant, feature-rich promotions that capture email addresses and social profile data early in the conversion funnel. It increases your brand's social influence by helping your customers follow and share your brand while identifying the customers with social reach for follow-on campaigns. So Gatsby is opening a private beta of their API, and it's useful for developing an in-house promotion or connecting the user data of your customers with the Gatsby app. You can do A/B testing on multiple campaigns. You can automate retargeting. You can generate promo codes and geo-fenced promotions. There's lots of other features, and if you're interested in trying out the Gatsby API for your promotions, contact API@thinkgatsby.com. That's API@thinkgatsby.com. Thanks to Gatsby.
Wow!